We're going to look at more multiplication properties of exponents and how we can use the multiplication property of exponents to multiply powers. So if we think back to what things mean, here we have 2 squared to the 3rd power. What that's telling us is that we have 3 of these things. So let's kind of write that down. 2 squared times 2 squared times 2 squared. There's 3 of those. So far we're in agreement. Then what happens is these each split up into 2. And we can see that I have 6 2's that are green. So really what we're saying is that this means 2 to the 6th power, that there are 6 2's. Now how can we take this and make a rule for it? Well, the way we can do that is we remember that parentheses means to multiply. We have 2 times 3. We're going to distribute that 3 out to the 2. When we distribute, we always multiply. So the exponents are distributing out. We have 3 times 2, so that's going to give us 6. And so there we have 2 to the 6th power. So let's take a look at some more and see if we can apply this. So here I have an example 1. I have g to the 5th power and the whole thing raised to the 4th power. And what we would do is we would multiply, because we'd give out, distribute that exponent of 4 to the exponent of 5, and that would give us a g with now an exponent of 20. If you can visualize that there are 4 of these, g to the 5ths, and if we added them all up, we would have 20 of them. Here, if we're looking at this problem, 2x to the 5th, and we want this 3 times, think about what this is saying. We need this 3 times. So 2x to the 5th times 2x to the 5th times 2x to the 5th. How can we use this rule of raising a power to a power here? Remember that the exponent's going to distribute out. I'm sure everybody can see that we're going to get x to the 15th. That part's pretty obvious. The question will be, what happens to that base of 2? Well, this base of 2 up here has an exponent of 1. So when we distribute the 3 out to that exponent of 1, we would get 3 times 1, which would give us an exponent of 3. And as you can see over here when we wrote it out, we did have 3 2's. And that's what gives us this. Now because this is an exponent of 4 or less, we should keep going. When we reduce that, 2 times 2 times 2 is 8, and we end up with 8x to the 15th power. Now let's talk about what happens with negatives, and let's look at 2 problems side by side here. The first one, I have negative 2 to the 3rd, and the whole thing is raised to the 3rd power. And the fourth one, I have negative 2 to the 4th, all raised to the 4th power. So when I look at this first one, this will turn out to be negative 2 to the 9th power. When I look at the second one, this will be positive 2 to the 16th power. Why is that happening? Well, let's take a look again about what we talked about, distributing and multiplying. 3 times 3 is going to give us that 9. And remember, a negative sign is like a negative 1. So if I have 3 negatives or 3 negative 1's, what that does for me is says that, hey, this is going to remain negative. So I've got to make sure the negative sign is there. Over here, 4 times 4, there's that 16. And this is saying I need 4 negative 1's. Well, 4 negative 1's are going to be a positive because every 2 negatives make a positive. So that is why this turns out to be positive. So we want to keep an eye on what's happening there and remember about the odds and the evens with that. Now let's take a look at one last example. Here we have negative 3 squared and the whole thing squared. So if we think about it, this negative sign has nothing to do with what's going on out there. It's saying, hey, take the opposite of whatever this may be. Well, when we give the 2 out here, we know that we have 3 to the 4th power. And so we still want the opposite of whatever 3 to the 4th power is. If I was to write this out in expanded notation, I'd have negative 1 times 3 times 3 times 3 times 3. And once I multiply all that together, I get negative 81. So hopefully you'll understand a little bit more about raising a power to a power.